Hi guys, there was a question from section 1.2, number 27, and one of the homework. Let me go ahead and see if I can work it for you. This is section 1.2. The problem was number 27. It's actually a special problem because it does require maybe a little bit of, I guess, thinking about the difference of two squares, how it factors. I know most of the time you get a perfect squares, but sometimes you actually can make it into a perfect square by taking this square root. Anyway, let me just explain. By the way, this approach is called algebraic approach in finding limits because most of the time you end up doing some algebra, namely factoring and things like that, okay? So here's what we are asked to do. We are asked to find the limit as x approaches 9 of 9 minus x over the square root of x minus 3, okay? So the first step, of course, as the instruction mentioned, that when you plug in 9, this is the first step. Anytime you want to find the limit, you take the number that x is approaching, replace all the x's with that number. Now, if you don't get a 0 in the bottom, that number will be your limit. Of course, here, these are special cases. As you plug in 9 in place of x, of course, the top becomes 9 minus 9, which is 0. And also the bottom becomes a square root of 9, which is 3. And again, 3 minus 3. So these are the one we call the special form 0 over 0. Okay, so for these, usually once you do some algebra, you should be able to find the limit. Even though right now the bottom is 0, but the fact that the top is 0, there is hope that we may find the limit. Now, as you know, there is a difference of two square formula. So when you have difference of two square, now you may say, well, sir, this is not a square. Well, 9 is, of course, a perfect square. But anytime you have a number or expression that is not a perfect square, if you take it as a square root, and then, of course, square that, and that gives you the same thing. In other words, you can always make anything into a perfect square. So let me just rewrite that. So we're going to look for the limit as x approaches 9. Now, we're going to write 9, of course, as, let me just kind of put that here for you. So 9 becomes actually 3 square. And then, of course, x, even though it's not a perfect square, but we can think of it as a square root of x squared. Because, you know, anytime you square the square root, it actually gives you the same thing back. So this is how you can turn this actually into a perfect square. So now that we have a perfect square, as you remember from algebra, that factors to 3 plus that expression, which is the square root of x, and then times 3 minus the square root of x. And that's come from what we call difference of two squares. Now the bottom, of course, is still the same. So now, as you can see, I'm sure you want to cancel those, except the problem is this is 3 minus the square root of x, this is square root of x minus 3. So to make this the same, you can either factor a negative from these two terms, or you can factor a negative from those two terms. Either one, once you factor a negative, it switches the sign. So it doesn't matter which way you do it. So I'm going to go ahead and do the top one. So actually, since this is by itself, let me just do the bottom one. So we can write this as limit as x approaches 9. So the top, everything is stay the same. 3 times plus the square root of x times 3 minus the square root of x. But the bottom, I'm going to go ahead and factor the negative out, which of course will turn the negative 3 into a positive 3 and turn the square root of x into a negative square root of x. Because it's a trick. Anytime you want to change the sign of two terms, just factor a negative out. And by the way, you can check it in case you want to make sure it's the same thing. So if you distribute the negative, negative times 3, of course, becomes negative 3, and negative times negative square root become positive square root. Okay, so now we can cancel these two same factors. Let me move it upstairs. So after you cancel, don't forget, you still have the negative, of course. So from there, this becomes the limit as x approaches 9. But the top is still going to have 3 plus the square root of x remaining. Now remember, we cancel the factor of 3 minus the square root of x. But of course, on the bottom, you still have negative 1. Because once I cancel, you still have the negative. So we're now ready to plug the 9 in, because right now there is no 0 on the bottom anymore. So as we replace all the x's with 9, let's see what is that going to turn out to be. Sorry about that. Let me adjust my... So as we go up here, again, we cancel the 3 minus the square root of x's. So you're just left with 3 plus the square root of x. But of course, you still have the negative in front that we have to factor out. So I'm just going to write that as negative 1. So now as you plug in number 9 in place of x, that becomes 3 plus the square root of 9 all over negative 1. Of course, the square root of 9 is 3. So that's 3 plus 3 over negative 1, which is 6 over negative 1, which of course becomes negative 6. Okay, so there is your limit as x approaches 9 of that expression. Okay, I hope that helps.